then benchmark. Okay, benchmark is FTSE All Share Index, and the return is 9%. Standard deviation of is 8%. So basically, we can calculate Jackson's alpha, Sharpe ratio, and Turner ratios. So Jackson's alpha, basically, we compare the market expect return with the theoretical expect return. So this is like market return of the ETF and subject by the theoretical return calculated by the Japan model. Okay, just plugging the value, so we can get alpha for fund 1 is 0.6%, and alpha 2 for equity fund 2 is 0.2%. Okay. So what does this alpha value mean? Which one performs better? What about performance comparing to the benchmark? Which one performs better?
A, the first one.
Okay, the ETF one, right? The first ETF performs better because alpha of it is higher than that of ETF 2, okay? And better than the market, right? Okay, so normally we expect a positive abnormal return. So alpha indicates the abnormal return, right? When the fund managers always seek for the abnormal return, positive abnormal return, okay? So if we have this kind of question in exam, we need to calculate that correctly and also explain that, okay, in terms of which fund performs better and why that. And then Sharpe ratio. So this is the equation, right? So it's the excessive return of the portfolio or the fund divided by the standard deviation, the total risk of this portfolio. Okay, so we got the mean return of this fund, we got a risk-free rate which is 1%, and we got standard deviation. Just plug in the value. So the Sharpe ratio for ETF 1 is 1.17%. Sorry, 1.171%. What does it mean? 1.17, what does it mean? Any ideas? Yeah, what does it indicate?
For every 1% change in market, the stock price will go or change the
Okay.
time.
Okay, more or less. So here is not the market risk, it's the total risk. Okay, standard deviation is the proxy of the total risk. Okay, including the specific risk and the systematic risk. Okay, so here 1.17 means that investors could receive 1.17 units of the return. Okay, 1.17% of the return after undertaking 1% of the total risk. Okay, so this is the reward for the after undertaking the risk. And similarly, we could get the Sharpe ratio of ETF 2, which is 0.9%. Okay. So for Sharpe ratio, we also need to compare it with benchmark. We also need to calculate the Sharpe ratio for the index. Okay. So here is the 1. So given the Sharpe ratio of these two funds, the benchmark, which one performs best? Which one performs the worst?
Fund 1 performs best.
Yeah, fund 1 performs the best, and
Fund 2 performs worse than the
yeah, very good. So we can just compare the value of the Sharpe ratios. The higher the better, right? So the ETF 1 performs best because it's the highest value. Okay, and then benchmark, which is 1, and then fund 2 performs the worst. Okay. Then Turner ratio. Turner ratio is basically a ratio to measure the reward after undertaking the market risk. Okay, so Sharpe ratio is a reward to risk. Okay, that risk is the total risk, and here is the systematic risk. Okay. So since the market beta is 1, therefore the channel ratio for benchmark is just the excess return of that market. Okay. So again, marginal value we can get channel ratio for all these funds and benchmark. Okay. Again, the higher the better. So fund 1 performs the best. Okay. So we can basically assess the performance of these two funds by considering the value of these different ratios. Okay, so abnormal return, fund 1 gets the highest abnormal return. Right, Sharpe ratio, yeah, we also could get highest reward, right? Highest Sharpe ratio, right? And then channel ratio. So definitely fund 1 performs the best. Okay. Is that clear? Any questions? No questions?
Sure, yes, I thought so.
All good? All good? Okay? Yeah.
So, did we miss one?
Which miss what?
So we there's no, there is no.
This is our first Sharpe ratio and then channel
There is
ratio.
not Sortino rush.
Yeah.
So in which cases you're using Sharpe ratio and in which cases you're using trend ratio, because it's very similar, but
Yeah, so we can
in which
assess it
scenario
by
is-
taking look at all these ratios. So sometimes Sharpe ratio of some fund is not that good, but it has a higher channel ratio. It means that there could be some, so it's not well diversified for this kind of fund because the Sharpe ratio actually is not that good comparing to the other funds.
so the difference is actually calculating the unsystemic risk too,
Yeah.
right? So it means that it's not well diversified.
Yeah, exactly. Yeah. Okay. So we need to check both the Sharpe ratio and the channel ratio. Okay. Is that all right? So next question, define and distinguish Sharpe ratio from Sortino ratio of a portfolio. Okay. So given this question, we need to explain like how we calculate Sharpe ratio and then Sortino ratio. Okay. What kind of equation that we use? What's the difference between these two ratios? Okay. So we remember Sharpe ratio, right? We just calculate Sharpe ratio. So can we define Sharpe ratio? Yeah. Sorry? Close, mean divided balance. Is that it?
Basically, Sharpe ratio is to calculate the valuation asset, how much quality of asset it has, so that if the portfolio is strong, you can invest in it.
Okay, good. Okay, so Sharpe ratio is how much excessive return that we can earn after undertaking total risk. Okay, so not just the mean return of that portfolio, but how much is the mean return in excess of the risk-free rate, and then over the standard deviation. Okay, so this is Sharpe ratio. What about Sortino ratio? Do you remember Sortino ratio? What is Sortino ratio? Sorry? Portfolio return is also a portfolio return. And what kind of risk? Risk-free rate. Risk-free rate means no risk. What is Sortino ratio?
So it's the same as Sharpe ratio, but it's considering the downside risk.
Okay, very good. Okay. So Sharpe ratio, Sortino ratio, channel ratio are all similar. The difference is the denominator. Okay. The numerator is all the excessive return. Okay. So it's the mean return subtract the risk-free rate. That is the numerator. and the denominator is different. Sharp ratio, that is total risk, right? Standard deviation. Channel ratio is the systematic risk, okay, that is beta. And Sortino ratio is actually downside risk. Downside risk, okay? Normally the market could be more volatile when the price go down, okay? And this is the risk that we don't like, okay? So remember, total risk is the standard deviation. Basically, standard deviation measures how much return deviates from the mean return. So the return could it be above the mean return or below mean return? We only consider those parts below the mean return, okay?
And the denominator of the Sortino ratio is target semi-variation, that is square root of target semi-variance.
Yes, the downside risk.
Okay.
Yeah, downside risk. So this is the equation actually to calculate the variance. Okay, so there should be a square here. Variance of the return. So it could be the total risk, but there are some constraints there. Okay, we only consider downside risk. So if the return is above mean return, we set it 0, and then if it's below, we take the whole value of that. Okay, and then take the square value of this deviation, and then sum them up, and then divided by the number of observations. Okay, so for example, if we consider the downside risk of portfolio in this year, so if we use necessary return, there should be 12 observations, right? So if we consider total risk, then definitely all these 12 months return are taken into account. But if we calculate the downside risk, probably there are 8 or 6 monthly return will be taken into account. Okay? So the more downside risk there, the more number of observations there, take into account the higher risk that assets could be. Okay? So these are the differences between Sharpe ratio and the Sortino ratio. Okay? Normally, if the market is highly volatile, we consider Sortino ratio. Okay? So we consider how much return, how much reward that we can have after undertaking that high risk. Okay, is that right? Is that good? Okay, so this is a Sortino ratio. Yeah, and another question is about money-weighted return. We need to calculate money-weighted return. Okay, so we got a table showing the cash inflow and outflows on different dates, okay? And then we calculate the money-weighted return. So it happened to be 1 year period, okay? So for answering this kind of question, we can simply use the spreadsheet. Okay, so I got the table here. We have already had these cash flows, right? And the money-weighted return basically equals to internal rate of return. So calculate this kind of return is very simple. We just use the IRR function and highlight all the cash flows. Okay, we already got these cash flows clearly in each period. And then that's it. Just highlight that and you get the money-weighted return is 0.85. Okay. And then we can convert it to annualize the return, 7.237. Okay. You will remember how to do that. You calculate and annualize the return. So it's just as what we did in the coursework. To the power of 12. Okay, so this is already get that. Okay? So you probably will use that more often in the next term when we study the financial analysis module. Yeah. Okay, so this is about tutorial questions for lecture 11, performance measurement. And then in lecture 12, we learned performance attribution. Okay, we break the excess return. Okay, so the return of the portfolio in excess of the benchmark. Okay, not the risk-free rate. We break it down and into 3 parts. Okay, that is asset allocation effect, security selection effect, and interaction effect. So do we remember how to do that? Do we know how to do that? Can we try to work on that? I'll give you 10 minutes. Is that all right? 10 minutes, work on that, please.